Hello guys, having seen in the first chapter about matter in our surroundings, the obvious question that now arises is matter around us pure? So in this chapter we will try to answer this question. A brief outline of this chapter is the introduction, then we will move on to what is a mixture, we will try to answer what is a solution, then we will learn some techniques of separating components of a mixture. We will learn about physical and chemical changes, and in the end, we will end the chapter with what are the types of pure substances. So let's begin. We consume a lot of products in our day-to-day life. These include milk, ghee, water, grains, and many more. So how do we conclude that the product that we use is pure? In common language, pure means no adulteration. In terms of science, pure has a different meaning. These products are a mixture of different compounds, and hence the term in terms of science, these are not at all pure. For example, milk is actually a mixture of water, fat, proteins, etc. And hence, in terms of science, milk cannot be considered as a pure substance. When a scientist say that something is pure, it means that all the constituent particles of that substance are the same in their chemical nature. A pure substance consists of a single type of particles. So what is a mixture? Mixtures are constituted by more than one kind of pure form of matter, known as a substance. A substance cannot be separated into other kinds of matter by any physical process. An example of this is sodium chloride when dissolved in water can be separated back by evaporation. But sodium chloride here is a substance in itself and cannot be separated into its chemical constituents that are sodium and chlorine by any physical process. A mixture contains more than one such substance. So what are types of mixtures? Depending upon the nature of the components that form a mixture, we can have different types of mixtures. These are solution, colloid, and suspension. Let's first see what is a solution. A solution is a homogeneous mixture of two or more substances. We can also have a solid solution and a gaseous solution. The example of solid solution are the alloys, and the example of gaseous solutions is air. In a solution there is homogeneity of particle level. For example, lemonade tastes the same throughout. This shows that particles of sugar and salt are evenly distributed in the solution. A solution has two components. They are solvent and solute. The component of a solution that dissolves the other component in it, usually the component that is present in higher amount, is called the solvent, which is water in case of lemonade. The component in the solution that is dissolved in the solvent, which is usually present in lesser quantity, is called the solute, which is sugar in case of lemonade. The other example can be a solution of iodine in alcohol, also known as the tincture of iodine. In this, iodine is the solute and alcohol is the solvent. Now let's see some properties of solution. A solution is a homogeneous mixture. The particles of a solution are smaller than 1 nanometers, that is 10 raised to the power of 9 meters in diameter. So, they cannot be seen with our naked eyes. Because of very small particle size, they cannot scatter a beam of light passing through the solution. So, the path of light is not visible in a solution. The solute particles cannot be separated from the mixture by the process of filtration. The solute particles do not get settled down when left undisturbed. That is, a solution is a stable thing. Now how do we calculate the concentration of a solution? At any particular temperature, a solution that has dissolved as much solute as it is capable of dissolving is said to be a saturated solution. That is, when no more solute can be dissolved in a solution at a given temperature, it is called a saturated solution. The amount of solute present in the saturated solution at this temperature is called its solubility. If the amount of solute contained in the solution is less than the saturation level, it is called the unsaturated solution. So, these three things have to be remembered. The concentration of a solution is the amount of solute present in a given amount by mass or volume of solution, or the amount of solute dissolved in a given mass or volume of solvent. So, concentration is nothing but amount of solute divided by amount of solution. Now, as the amount of solution is almost equal to the amount of solvent, concentration can also be written as amount of solute divided by amount of solvent. There are various ways of expressing concentration of solution, but here we will only learn about two methods. The first one is mass by mass percentage of solution. So mass by mass percentage of solution is nothing but mass of solute divided by mass of solution. Now similar to this, we have mass by volume percentage of solution. So this is mass by mass percentage. Mass by volume percentage solution is mass of solute divided by volume of solution. Let's look at a problem. A solution contains 40 grams of common salt in 320 grams of water. We have been asked to calculate the concentration in terms of mass by mass percentage of solution. So we had seen that mass by mass percentage is nothing but mass of solute divided by mass of solution. Therefore, in this case, the mass of solute is given to be 40 grams and mass of solution is mass of solvent plus mass of solute. So this is nothing but 40 divided by 40 plus 320, which is 40 divided by 360, which is nothing but 1 upon 9. Now to get it into percentage, this has to be multiplied by 100. So this becomes 11.1%. So I'll write this mass by mass percent as mass of solute upon mass of solution into 100, and mass by volume percent as mass of solute divided by volume of solution into 100, because we are calculating it in terms of percentage, therefore we have to multiply it by 100. Okay, so moving forward, what is a suspension? A non-homogeneous system in which solid is dissolved in liquid is termed as a suspension. A suspension is a heterogeneous mixture in which the solid particles do not dissolve but remain suspended throughout the bulk of the medium. Particles of a suspension are visible to the naked eye. What are some properties of the suspension? Suspension is a heterogeneous mixture. The particles of suspension can be seen by the naked eye. The particles of suspension scatter a beam of light passing through it and make its path visible. The solute particles settle down when a suspension is left undisturbed. That is, a suspension is unstable. They can be separated from the mixture by the process of filtration. The third type of mixture is the colloidal solution. The particles of colloid are uniformly spread throughout the solution. Due to the relatively smaller size of particles as compared to that of suspension, the mixture appears to be homogeneous. But in reality, a colloidal solution is a heterogeneous mixture. For example, milk. Because of the small size of colloidal particles, we cannot see them with naked eyes. But these particles can easily scatter a beam of visible light, as shown in this picture. The scattering of beam of light is called the Tyndall effect, after the name of the scientist who discovered this effect. Tyndall effect can also be observed when a fine beam of light enters a room through a small hole. This happens due to the scattering of light by the particles of dust and smoke in the air. Now let's look at some of the properties of a colloid. A colloid is a heterogeneous mixture. The size of particles of a colloid is too small to be individually seen by naked eye. Colloids are big enough to scatter a beam of light passing through it and make its path visible. They do not settle down when left undisturbed, that is, colloid is quite stable. They cannot be separated from the mixture by the process of filtration, but a special technique of separation known as centrifugation can be used to separate the solute from the solvent. The components of colloidal solution are the dispersed phase and dispersion medium. The solute-like component or the dispersed particles in the colloid form the dispersed phase, and the component in which the dispersed phase is suspended is called as the dispersing medium. Let's see some of the types of colloid. In case of the dispersed phase to be liquid and dispersing medium to be the gas, it is known as aerosol. For example, fog, clouds, and mist. When dispersed phase is solid and dispersion medium is gas, it is again aerosol. So basically, when the dispersing medium is gas, it is known as aerosol. When the dispersing medium is liquid and the dispersed phase is gas, it is called foam. When the dispersion medium is liquid and the dispersed phase is also a liquid, it is called an emulsion. For example, milk and face cream. When the dispersing medium is liquid and the dispersed phase is solid, it is called sol. For example, mud and milk of magnesia. When the dispersing medium is solid and dispersed phase is gas, it is called foam, which is rubber, sponge, pumice, and foam. When the dispersing medium is solid and the dispersed phase is liquid, it is called gel. Example, jelly, cheese, butter. And in the end, if the dispersing medium is solid and the dispersed phase is also a solid, it is called a solid sol. The examples of which are colored gemstone and milky glass. With this, we come to the end of the first video of this chapter. Thank you.